common application of Bernoulli's equation is to determine pressures and velocities inside a fluid. And for this, what we can oftentimes use is what's called a pitot-static tube. To discuss a pitot-static tube, let's consider one step back. And first, let's consider a piezometer. A piezometer measures the static pressure inside a fluid. So it's simply a hole on the side of a fluid, and the rise in water column will correspond to the static pressure. A pitot tube, on the other hand, measures the stagnation point pressure or the stagnation pressure of a fluid, and so it basically slows the fluid down to a velocity of 0, and so we're combining the dynamic and the static pressure into the stagnation pressure, and that's measured by a pitot tube. A pitot-static tube now combines both of these by adding little holes, static pressure tabs, on the outside of the pitot-static tube, and so thereby it allows us to measure the velocity of the fluid by measuring the stagnation pressure and the static pressure. And we already looked at an application of this during the first class period when we looked at this scenario where we had a piezometer and a pitot tube, and we used those to determine the velocity within our fluid system. We first made assumptions, steady state and incompressible. We looked at the physical laws, which was Bernoulli's equation. We identified the static pressure, dynamic pressure and hydrostatic pressure, and then we applied Bernoulli's equation to solve for the velocity in this fluid based on the pressure measurements. And so this is an example application of Bernoulli's equation for pressure and velocity measurements in fluids.